This is part 9 of square roots and radicals, and in part 8 we discussed cube roots and fourth roots, etc. So just to recall, if you have a little 3 in here, like let's see, how about cube root of 56? This is red. Cube root of 56. If you have something like the fourth root of 48, this is red, the fourth root of 48. All right, now, and then we had our perfect cubes and our perfect fourths. In other words, you multiply a number times itself 3 times, it's a perfect cube. 4 times, it's a perfect fourth, etc. So let's take this cube root of 56 again, and remember how we can simplify that. We want to say, is there a perfect cube that's a factor of 56? And if you're not sure, go ahead and make a factor tree and see if you could find it. So you might say, 2 goes into it, and let's see, 2 goes into 28, and 2 times 7. So you notice you got 1, 2, 3 factors of 2. There you are. So there's your perfect cube, 2 times 2 times 2 times 8. Or you might have just realized 8 times 7, which is how I usually write it. It's up to you if you want to write that as 2 cubed or write it as 8. And then the perfect cube gets out. So that the answer here will be 2, and what's left inside is the cube root of 7. Now a lot of people forget to put that little 3 in there, which means if you don't write the 3, then that means 2 times the square root of 7. So you have to be careful of these little details. All right, we also talked about if you had positive numbers for bases, so as long as b is greater than or equal to 0, for sure, that this is simply equal to b. So if you've got nth root of b to the nth, it's b. So the reason I'm writing that is, notice if I had written 8 instead of writing it as 8, I wrote it as 2 cubed times 7. That's another way of seeing when you take the cube root of 2 cubed, the 2 is what gets out. Okay? Now, when I say b is greater than or equal to 0, that actually has to happen if n is an even exponent, but if it's a negative exponent, it doesn't have to happen. But we will, for now, just deal with the positive values of b, and later we'll go on to some negative values. For the problems on this video, we'll assume all variables represent positive numbers. We also did some problems with the variables under the cube root, and remember that in order to be a cube root, the exponent has to be a multiple of 3. So when we redo this one, rewrite it, we want to write it as perfect cubes under here. For 24, 8 is a perfect cube, and that's a factor, so I can write 8 times 3. And for x to the 10th, 3 doesn't go into 10, but I could write that as x to the 9th. You're going to pick an exponent 3 goes into, the one right below it, times this extra x to the first power, which I could write as x. And then cube root of 8 we could take out as a 2. Cube root of x to the 9th, remember we just take a third of the exponent, which means you divide by 3, and that's x cubed. So what comes out here is the 2x cubed comes out in front, and you're left inside with cube root, right? Don't forget the little 3 inside that little space, 3x. Now let's look at this one more time, this cube root of x to the 10th. If you don't want, you might notice that if you divide 3 into 10, it goes 3 times. That's going to tell you how many times, how many x's get out, x cubed. So if you do 3 into 10, and then the remainder is the new exponent inside. So notice what I have here. If I divide 3 into 10, there's the 3, remainder 1. Let's see if you can do that on this problem. X to the 26. All right? Try that on your own. Put it on pause. Okay, using that little nifty trick, you're going to say, well, how many times does that get out? 3 goes into 26 how many times? 8. And then, oops, I did this wrong up here. I forgot the little 3. What's left is your remainder, right? 3 into 26, 8 remainder 2. It's going to be x squared. So if you'd like to do that, it's okay. If not, stick with my original way of writing x to the 26 as x to the 24th times x squared, and at the next step you'll get the same thing, right? You'll take out an x to the 8th from that x to the 24th, and you'll be left with that x squared underneath. And then be careful that you remember to write the index in here. It's very easy to forget that, and then if you don't do that, you're talking about square root. All right, here's a challenging problem. The 4th root of 80 x to the 12th y to the 15th. Put it on pause and see if you could figure it out on your own first. Okay, so here we go. I need to write this as perfect fourths. Now, 80 is not a perfect fourth. In other words, there's no whole number that you multiply times itself to get 80. So you have to think of what numbers go into 80 that are perfect fourths. And when we're getting up to fourth and fifths, I'm thinking like 2 to the something. And in fact, 2 to the 4th power is 16, and that's a perfect square. That's a perfect fourth. 16 times 5 is 80. So 16 is your perfect fourth. Now, the other way to do this, remember, is to do a factor tree, and you'll see that you have 2 times 2 times 2 times 2 times 5. That's another way you could figure that out. X to the 12th, that is a perfect fourth because 4 goes into that exponent already, so I can leave that x to the 12th. And for y to the 15th, 4 does not go into 15, so I'm going to write that as y to the 12th times, I've got these extra 3 factors of y. And now, the perfect fourths. 16, a 2 comes out. All right. The 4th root of x to the 12th, remember you do 4 into the exponent. And y to the 12th will give me a y cubed that comes out. So what do I end up with here? Up on the top tells what I was able to take out of the 4th root. So I've got 2x cubed, y cubed, 4th root, right, of what's left. I've got the 5 in the y cubed. Look carefully. 5y cubed. And that's it. That's your answer.